Hey everyone, you've heard of ChatGPT, right? Well, have you ever stopped to think about what that T actually stands for? It's for transformer, an idea that came from this one single game-changing paper in 2017 called Attention is All You Need. And today, we're going to dive into how this one concept didn't just tweak AI, it completely tore up the old playbook and wrote a new one.
So, here's the big question we're tackling. How on earth did AI go from spitting out kind of clunky robotic sentences to actually understanding language? Getting the nuance, the context, all the tricky stuff. Well, the secret lies in smashing through this one massive roadblock that was holding everything back.
Okay, so before 2017, the AI world was kind of stuck. Pretty much everyone was using the same basic approach to language, and it had this one huge fundamental flaw. It's what we call the sequential bottleneck. And this thing made building really big, powerful AI models just painfully slow and difficult.
Think about it. How do you read this sentence? You go one word at a time, right? Left to right. And that's exactly how the old AI models, things like recurrent neural networks or RNNs, work too. They processed everything in a line, sequentially. And look, that makes sense for us humans, but for a computer that can do billions of things at once, it's like forcing a supercar to drive in a school zone. It's a huge limitation.
And this really breaks down the why. Processing one word at a time creates this massive computational traffic jam. Plus, the model's memory wasn't great. By the time it got to the end of a long sentence, it would kind of forget what happened at the beginning. So connecting a word like it back to the thing it's talking about, super hard. But the real killer was this. You couldn't do the work in parallel. You literally had to wait for word 1 to finish before you could even start on word 2. Imagine trying to train a model on the entire internet that way. It would take forever.
And then 2017 happened. A paper drops with this incredibly bold, almost cheeky title, Attention is All You Need. And the idea inside was just as radical. It basically said, what if we just stopped doing things sequentially? What if we just threw that whole idea in the trash?
And this quote from the abstract, it just lays it all out there. Proposing a new simple network architecture, the transformer, based solely on attention mechanisms, dispensing with recurrence and convolutions entirely. That part, dispensing with recurrence, that's the key. That's them saying, we are getting rid of the one word at a time model. It was a total break from the past. Just incredible.
And here it is, the paper itself. It just looks like any other research paper, right? But what you're looking at is basically the blueprint for modern AI, the DNA of ChatGPT, of all the big models we use every day. It's truly one of the most important documents in the history of computer science.
So if you're not going word by word, what do you do? Well, they replaced it with this brilliant idea called self-attention. Now, instead of reading a sentence like a person, the model looks at the entire thing all at once. It's like taking a snapshot. And in that single moment, it can figure out how every single word relates to every other word, all at the same time. No more waiting in line.
Okay, I know this diagram looks intense, but don't worry, the big idea is actually pretty straightforward. See the left side? That's the encoder. Its only job is to read and understand whatever text you give it. The right side? That's the decoder. Its job is to write an output, maybe a translation or an answer to a question. And what's powering both sides? You see those boxes labeled multi-head attention? That's the engine. That's that self-attention mechanism we were just talking about, doing all the heavy lifting.
All right, so how does this attention thing actually work its magic? Let's pop the hood and take a look inside the real engine room of the transformer.
So we're zooming in now. Deep inside every one of those blocks from that last diagram, you'll find this. This is the multi-head attention mechanism. And folks, this is where the magic really, really happens. This is how the model learns all those subtle connections between words.
But hold on, why multi-head? What does that mean? Well, it's because the model isn't just looking at the sentence one way. It has multiple heads, or perspectives, all looking at the sentence at the same time. It's kind of like having a team of experts reading with you. One head might be tracking grammar, the subject and the verb. Another head might be a detective, figuring out what pronouns like he or it are referring to. They all work together, in parallel, to build this incredibly rich, deep understanding of the text. Okay, let's go one level deeper. I promise this is as technical as we get. What you're seeing here is the machinery inside just one of those attention heads. It has a fancy name, scale.product attention, but all you really need to remember are 3 words: query, key, and value.
Let's use an analogy. Imagine you're searching a database. The query is your search term. It's the word you're currently focused on. The keys are like the titles or keywords for every document in the database. That's all the other words in the sentence. And the values? That's the actual content of those documents, the meaning of the words. So for every single word, the model is essentially asking, okay, for this word I'm looking at, how relevant is every other word in the sentence? So here's how it plays out, step by step. First, the model takes its query, the word it's focusing on, and compares it to every single key in the sentence. This gives it a similarity score. Think of it as a relevance score. Then it takes all those scores and normalizes them, turning them into percentages that all add up to 100%. So one word might get a 90% relevance score, another gets 5%, and so on. Next, it multiplies each word's actual meaning, its value, by that percentage. And finally, it just adds them all up. What you get at the end is a brand new understanding of that original word, an understanding that's now blended with the meanings of all the other relevant words. It's brilliant.
Okay, but wait a second. There's a huge glaring problem here, right? If the model just looks at all the words at once, like a big jumble, how does it know about word order? This was the big aha problem the researchers had to crack.
Take the classic example. Dog bites man versus man bites dog. To a system that just sees a bag of words, those sentences are exactly the same. Same words, right? But for us, the meaning is, well, completely different. Word order is everything.
And the solution they came up with is just so clever. It's called positional encodings. Basically, before the words even go into the model, they get a little piece of extra information added to them. It's a unique mathematical signature that tells the model the exact position of that word. Is it the first word, the fifth, the last? It's like stamping each word with its own GPS coordinate, so the model never loses track of the order. Problem solved.
So we've got the problem, the sequential bottleneck. We've got the solution, self-attention plus positional encodings. So, did it work? What happened when this new transformer architecture was finally put to the test?
This, right here, is the payoff. This is called an attention heat map, and it's basically a window into the model's mind. When the model is trying to understand one word, the bright spots show us which other words in the sentence it's paying the most attention to. You can literally see the model forming connections and understanding context in real time. It's incredible.
And the results? Oh, the results were just mind-blowing. On a really common test for machine translation, the transformer didn't just beat the old models. It absolutely shattered the records. We're not talking about a small incremental improvement here. This was a massive quantum leap forward in quality. This wasn't just another step, it was a whole new staircase.
So at the end of the day, what's the legacy of this paper? It's everything. By killing the sequential bottleneck, transformers made training AI faster and cheaper. They gave us way better results. But the most important thing is that they were scalable. You could build them bigger and bigger, and they just kept getting smarter. They laid the groundwork for the huge models we have today. So yeah, that T in ChatGPT, it's everything. It's the engine that powers the entire modern AI revolution.
And that really brings us full circle. The big breakthrough of the transformer was seeing a fundamental limitation, processing things one by one, and having the courage to throw it out completely. And that unlocked a whole new level of scale and power. So it leaves you wondering, right? What's the next big bottleneck holding AI back today? And what crazy, out-of-the-box idea is going to be the one that smashes through it? Thanks for watching.